So, what do I think of the chainsaw? To be honest with you, this is a showpiece. It makes a great wall hanger, and it's not really a weapon.
As a mechanical solution, I don't think that would work terribly well.
Well, let's see what we can do about that. The idea of a whip sword has been around for quite some time. Most notably in video games like Soul Calibur with Ivy's Snake Sword, the Threaded Cane in Bloodborne, and of course most recently on the big screen with Raya and The Last Dragon. Naturally, seeing her whip sword in action sparked my curiosity, so for the last year I've been thinking about how to pull off a functional whip sword. I came across 5 major problems. First off, edge alignment. Bit of a controversial statement, but in order to cut something you need to hit your target with the edge. Otherwise, it's just a glorified metal rod. Jörg Sprave had the same issue when testing the wall hanger from earlier, and looking at all 3 examples from earlier you can see that these segments are connected by some sort of cable, which caused these segments to turn unpredictably, thus making edge alignment a real nightmare. Problem number 2. Even extension. Now if you were to swing that thing around it wouldn't look like this, but more like this, because the centrifugal force would pull all these segments to the very back. Congratulations, you've now got a blade on a rope. Problem number 3. Rigidity. I think Skelegram said it best in this video discussing the topic.
The problem with segments, of course, is it weakens the integrity of the blade. It's basically like having a pre-broken blade to try to fight with.
Let's be real, if you can't use it as a sword, it's just a bladed whip. Problem number 4. Making it retractable. Without a doubt, the cool part about a whip sword is changing from sword to whip mode on the fly. You could solve a whole lot of problems by just attaching some latches onto each segment so that you could lock it down while in sword mode and then open it to go back into whip mode. But let's be real, that kind of defeats the purpose of having both in one. And last but not least, all of the above have to fit the sword. This one seems like a no-brainer, but working within the size restrictions of a sword was pretty difficult. Especially the retraction mechanism has to be so small that it doesn't make the whole thing extremely unwieldy. I didn't want to have like a whole gauntlet that the sword connects into, but rather have a standalone item that you could use without any extra gadgets. So how do I pull this off? Pull off because, you know, it's retractable. Let's start tackling the first 3 problems by making the segments. I've bought 4 of these mild steel blanks. They are 2mm thick and 30mm wide, and they are going to make the housing, which are going to be 70mm long. Yeah, I know I shouldn't use my calipers for this, but I don't have anything else, so sue me. Okay, this is half of one segment, and I'm planning for 10 segments, which means I need a little bit more than this. Yeah, I think this should do. Alright, that's 20, but to make one segment I also need one of these and one of these. I want to try if I can get to multiplicate these tiny strips as well, so here goes nothing. This is not mild steel, but 15 and 20, because that will have a nice springiness once it's hardened and tempered. So, but first I need some more of these, so let's cut out some more. Alright, I've got all the dividers I wanted to make, and now I've got the slots roughly fitted, and that must have been the 2mm pieces from earlier, and yeah, seems like a late delivery, but we can move on now. The next step is to assemble the segment casings, and this was a pretty tedious task, so let's go over each step for one segment. First I had to check whether my drill vise was holding both pieces tightly. I had some issues with the test piece where one piece dislodged and screwed up the hole alignment, so this was just a precaution. Then I marked the hole, which are 12.5mm from one side and 60mm apart from another. Next I placed two pieces to get both sides 2mm away from each other. You'll see why in a second. Now I had to place the casing in a way that it had clearance beneath the hole to drill through and not hit the vise. I tapped the hole, put all thread in and then flipped the casing around to repeat on the second hole. The idea of the 2mm spacer was that the pitch of the thread remains true when everything is assembled, as it will be 2mm apart then. Lastly, I could cut off the excess all thread and then do the whole process again for the remaining 9 segments. Alrighty, now we've got each piece like this to reel in each part so that I get back into sawed mode. I'm planning for a steel wire cable to run through each of these threaded rods. Now the only thing I have to do is drill 2 holes through each all thread. I mean, how difficult can that be? I've spent probably the last 3 hours trying to get this done. This is how it was supposed to look. Now, what most of the time happened was something like this, where I've got 2 holes, but both holes are not parallel to each other, which makes it look very stupid. So this out of the way. Then the next problem was the ones where the drill just drifted to the side and created a hole out of the way. And yeah, I've tried a bunch of things, different fixtures. I also made like these little jigs. After 2 or 3 times of doing this, just gave a little bit away so that I've got the same issues as before. So I've came up with another idea. I think this one is acceptable, let's say. Let's call it a 2-part DIY hole for people that are too stupid to drill holes in a rod. It's just a working title. Now when I put both together, we've got a hole. Now for the blade I'm planning some high contrast twist Damascus, and for that I've got 2 kinds of steels. This one has a high nickel content which will edge bright, and this has a high manganese content and will edge dark. So we've got a nice contrast between silvery and black. But first I need to cut both and stack them. Okay, actually before stacking I need to clean up the pieces so that I get a clean forge web. So let's do that as well. Man, I just love this trick. Like a pretty sizable billet. Okay, I can go ahead and now weld this billet together. You can already tell with the first heat that the top layer is a lot cooler than the rest of the billet, which prevents a solid forge weld. I tried it again a few heats, but the problem remained, so I decided to cut off the 2 top layers to prevent problems down the line. The rest of the billet was nicely forge welded though, so now I could start to actually move some metal. I had to stop here because the billet was starting to shear apart, And now the next step is to cut it into 4 pieces and then restack it to quadruple our layer count. I didn't mention this earlier, but I've added another 8 layers of thick steel during the restack, so the billet now weighed close to 1 kilogram, which at that thickness felt like hammering a cold anvil. Needless to say, I was pretty exhausted after a few hours, so I decided to continue the next day. Unfortunately, in Germany we've got the Sonntagsruhe, which means that I'm not allowed to make loud noises on a Sunday, and I'm pretty sure smithing counts as a loud noise. So I packed up all my stuff and moved it to a place where nobody gives 2 shits about that sort of noise. Alright, and now this right here will be my workshop. Never mind the door, we're still pretty much in construction. Let's get this thing set up. So just my luck that I have a split right down the middle. I'm going to cut it off now and then twist each half of this. Let's see if I can salvage it. Boy, I almost forgot how much fun smithing is when you can actually see the material move. And there we have it, one half of the Damascus drawn out. You can clearly see a delamination spiraling all the way around the billet, but for time reasons I just couldn't afford to start over. Since this will just be a showpiece, I decided to go with aesthetics over functionality. To visualize the next step a bit better, let's look at this thing that looks faintly like a cow. These are the parts we've got right now. I'll make the casing transparent so we can have a look inside. Casings, dividers, holes, blade and top spacers. Now I need to somehow connect the blade to the casing. My idea was to take a 2mm piece of metal and then slip it into a slot in the blade and forge weld both together. That way I could secure the blade to the casing with some rivets, and we've got a lead for the dividers that also lets us control how much the dividers can articulate. Now I'm cutting a slot down the spine of our blade segments and preparing the metal pieces that go in there. For those of you that haven't seen my dagger challenge video and are now wondering why I'm using the world's tiniest vise, I actually live 2.5 hours away from the workshop I was filming at, which means I can only work on the project when I'm visiting my parents. So this is me trying to get some work done in my apartment at my desk. I temporarily superglued the top spacers in place so that I could check whether the segment dividers have enough room to properly articulate. Because I'm not very good at it, and because it's very easy to burn through thin Stockwell stick welding, my father-in-law was nice enough to autogenous weld these segments for me. I wired all these segment dividers together so I could dunk them all at once, and in my mind this worked a little bit better. And they got stuck. And now to harden the segments. You now might be wondering, didn't he say something about forge welding the blades a minute ago? Yeah, well, I found another solution. And I ran out of propane, so the forge wouldn't get hot enough, and I couldn't get any more that day, but that's besides the point. Epoxy will probably do the job just fine.
Oh, you stink!
Now that I've got these segments done, let's move on to the fourth problem, making the retraction mechanism. What I planned was to use the same principle a tape measure works with, but a lot stronger. So after taking one apart, I knew that I needed some kind of rolled up spring, and since I'm no expert and there isn't a single video explaining how tape measures work, I just ordered something that seemed to fit the job. So I got these two constant force springs. The way they work is that you've got the same resistance no matter how far they're pulled out. This works by putting the spring loosely on some kind of rod, because as you pull the spring, it rotates around the rod. In a tape measure, everything is encased, and once you open it, everything pops out and seems almost impossible to put back together. Believe me, I've got about 8 meters of tape measure sitting in one of my drawers, waiting to burst apart because I just couldn't put it back together. You see, the problem was that for my plan to work, I needed to fasten the end of the spring to the rod so that I could draw out the spring to loop back around itself. If I let go of that, the spring would then try to go back into its original position and thus roll up the metal wire. The only problem is that while looping around itself, the diameter of the spring shrinks a lot. And these springs were simply too small for 40 centimeters of draw length. And since I've paid around 40 euros to buy these two, I surely won't order another one. So I've played around with some different designs. Let's not talk about this one. And I've came up with something that works with these springs I've got. Okay, now this is what I came up with. How this works is that I've got a rod to place the spring upon, and then we've got two bearings to help and redirect the spring, so that I've only got like a short contraption to cover a lot of distance. So this all the way around with this bigger model is 50 centimeters of draw length on only 18 centimeters of space. And now I want to create a housing, obviously cover this side, cover the other side, so that this thing will be the handle. And now I need to create a housing with 15 millimeters of length to have a nice grip as a handle. Alrighty, so here's the prototype of the retraction mechanism. And now there's a couple of things I want to change about this particular design. As you can see, it gets stuck here. Oh, okay. Ow! It is a lot of fun to work with. Yeah, I've ordered some new bearings. These will be a lot smaller so that I can have a little bit more space in here, because as you can see, it is almost flush with the top side, just like this. And then you have to imagine that the steel wire is also connected. So I had an issue where you can see the scrape lines right here, where the wire got stuck between the top cladding and the wheel. 8 dividing segments in the whip blade, and each with a length of roughly 4 to 4.5 centimeters. 4.5 times 8 is 36 centimeters, and that means that I need a draw length of at least 36 centimeters within my handle. With this setup, we've got 10 centimeters, then the half of one bearing is 2 centimeters, so we've got 10, 12, over here roughly 24, 26, and then the whole length again with 12 is 38. More 39, with the half centimeters are left out everywhere. So we've got 39 centimeters of maximum draw length. Okay, I kind of hit a dead end with the mechanism. The resistance that the steel wire cable itself has, as you can see, if I just pull it, it's slightly protruding the top and bottom wall that will be there. I've got quite a lot of resistance once releasing it back. I don't know what to do about it, but now I figured that I might just start assembling the whole thing together, and maybe it's more useful if I test the mechanism once I've got the whole weight at the end of the blade to see how it works when in action. Now I'm cutting a slot into what will be my guard to attach the handle to it. I'm a f***ing idiot. Okay, I showed you that I finished grinding this in. Looks pretty decent, I'd say, and I think it also fits pretty good. But yeah, let me show you the problem. So it starts here, rolls around this side, goes around back, rolls around again, and then it is supposed to leave the handle, but it's meant to leave the handle at this side, not this one. I put the spring on the wrong side. If everything would be working without the top and bottom piece, it would just go like this. Fully went back. Now the problem is, once I add the top and bottom pieces, I've got a lot of compression going, so it gets squished in here and actually puts so much strain onto the spring that almost at every bearing it just gets caught in there. So okay, I had some time to think about how to go forward with this, and I only really see two solutions for this problem. I couldn't use any smaller diameter bearings because the resistance of the steel cable, as you can see, will be the same. It will still protrude out of the casing and it will get stuck again. I don't want to make the handle any bigger because this is the maximum I want to go with this. Since this is a fantasy build, I think I did some sketches and I think it suits the whole thing. I will take out one bearing and then make the handle longer so that I only have to go around one bearing. That way I don't have any spaces where the cable is directly on top of the spring, which was a big problem because it got stuck between the handle itself and the spring and the bearing. I'm actually kind of glad. You see, I put the new handle on here and I just really love the feel of this two-handed handle. Now the next thing before the camera dies, I have to connect the first segment of the blade on here, and I'll do it the same way I did this by cutting out a recess and then weld it from the back.
Hey, wake up. The talking part is over.
I know there was a lot of prototyping to take in, but it took me so many hours of revision to get a working model that it just didn't feel right to act like I got it right on the first try. But now let's kick it back into fun gear with some smashing of hot metal. What's this? Well, the two pieces of Damascus I planned for the tip segment decided to spontaneously combust, so I substituted them for this beefy piece of lawnmower blade. Actually, for the next frame to make sense, we have to go back a little bit. I wanted to add some decorations to the segment, so I drew up this knotwork that works while in sawed as well as in wood mode. I know I'm skipping over some parts, but at a certain point it's just repeating the same thing over again, and I think by now you've understood how the belt grinder works. Speaking of repeating the same thing, did you know this build is part of the Fantasy Knife Challenge? We've got fantastic knife makers in a friendly competition to make their fantasy build, and you, the viewers, are the ones voting for the top spots. Check the link in the description or my pinned comment for the voting form and a playlist to all the other builds. But wait, there's more! While you're in the description, check out our challenge sponsors that were nice enough to provide huge prizes for the viewer build section. It's now the last day I have to work on this project and I have yet to start making the brake system. The brake is so important because it helps secure the rigidness in sword mode while also allowing you to keep it locked in whip mode. So this definitely isn't something I would want to miss for the showcase. Okay, it's not as pretty as I would want it to be, but I'm running out of time. So now we can slide these springs into place. Just tapping it in there. Now this thing is locked. And now to make the trigger to disengage the brakes, so it goes back. Bit of a stupid mistake. I used mild steel for this part, and the force of the spring bended so that the pressure was getting less and less. So I switched it out for a piece of lawnmower blade, which is some kind of tool steel, so I should get a decent hardness, and I also switched the angle of the slit this way to make it a bit more clean. This piece securing this lever, and then camera, and then this piece securing this lever. And now, after roughly 3 months of work, I could finally put on as much protective clothing as I could find and test out the Fantasy Challenge whip sword.